Hey guys, we are back with another question from September 2020 exam. This is a question he is given E. This is the current. Okay, so is given current E is equal to 140 sine 314 t. It's the AC current. Okay, and you need to find peak current, average current, RMS value, instantaneous value at 3 milliseconds, frequency, time period, peak factor, and form factor. Okay, some several parameters we need to find from the given AC current. So how do we do that? Okay, this is very simple. We need to compare this with the standard form. What is the standard AC definition or the standard AC denotation? Okay, we denote AC values like this. E is equal to Em sine 2 pi f t. Okay, so peak current or maximum value. Okay, peak current or maximum current. Okay, is Em. So Em, peak current or maximum current is Em. What is Em? If you compare this and this, Em is 140. Okay, Em is 140 amperes, right? Okay, so an AC current, an AC quantity is generally like this. In this axis we have time T, okay, and here it is E. We have E, and the AC signal will be something like this. Okay, and the maximum value is this value. This is E M. Okay, what is the second one? Second one is the average current or the average value. E average is given by 2 Em by pi. Okay, so average value is 2 Em by pi, so that is 2 into Em is 140 divided by pi is 3.1415. Okay, so what is the average? The average value is 89.13 amperes. So you use your calculator and find the average value. So peak value is 140. So this value is 140, and 89.13 will be somewhere here. It's like more than half and less than very here. This is the E average. Okay, and finally RMS value of current is E RMS, or simply E is Em by root 2. Okay, or that is 140 by root 2, because Em is 140. So what is 140 by root 2? That is 98.99 amperes. Okay, so 98.99 is greater than 89. So E RMS value is greater than E average value but less than Em value. So E RMS will be somewhere here. So this is E RMS value. Okay, this value here. So Em is E average. Okay, so that's for Em peak current, average current, and RMS value of the current. Before going to instantaneous value, let me first solve frequency and time period. So what is frequency? Frequency F is cycles per second. Okay, so this is one cycle. Okay, one waveform is one cycle, and how many such cycles are there per second? Okay, in a second, how many times the wave goes up and comes down and reaches zero again? Okay, this is time axis, right? So how do you find frequency? Frequency is F, and we know 2 pi f. 2 pi f is 314, right? So that is 2 pi f is 314. That means f is 314 by 2 pi. This 2 pi, if you send it inside, it will be in the denominator. 2 into 3.1415. Okay, so f is equal to 50 hertz. So there are 50 cycles in a second. Hertz is cycles per second. Okay, in a second a wave goes up and comes down 50 times. Okay, so if there are 50 cycles in a second, then time period is second per cycle. T is second per cycle. So how much time will it take for the wave to go up and come down one time? Or what is the time period of one cycle? Okay, that is T. Time period is time taken for one cycle. Okay, that is simple. If there are 50 cycles in 1 second, then per cycle per cycle we have 1 over f, we need 1 over f seconds, okay. That is 1 by 50, that is t is equal to 0.02 seconds. Okay. So this value here is 0.02 seconds or 20 milliseconds. This is time axis, okay. So in 20 milliseconds or 0.02 seconds, the wave has completed one cycle. Okay. So frequency and time period are inversely proportional, okay. And then now we'll come to instantaneous value. Okay. So instantaneous value at t equal to 3 milliseconds. Okay. So in this waveform, and this is t axis, right? So where is 3 milliseconds? If it is 20 milliseconds here, this will be 10 milliseconds, and this will be 5 milliseconds. The 3 milliseconds will be somewhere here. T equal to 3 milliseconds. So at this point, if you draw a line here, what is this value? What is the value of current when t is equal to 3 milliseconds? That is instantaneous value of current. Okay. So how do you find that? So E when t is equal to 3 milliseconds is 140 sine 314 into 3 milliseconds. In place of t, substitute 3 milliseconds. That is 0.003 or 3 into 10 power minus 3. Okay. And remember, you have to keep this in radians when you are using your calculator. Okay, this is not in degrees, it's in radians. So E when t is equal to 3 milliseconds is, the value is 113.22 amperes. Okay, so this value here, this value is above ERMS and average, E average. Okay, so at when the time is 3 milliseconds, the value of current is 113.22 amperes. Okay, and finally peak factor and form factor. So what are these values? These are ratios. Okay, peak factor and form factors are ratios. Okay, peak factor is Kp and form factor is Kf, and peak factor is the ratio between the peak value, okay, or the maximum value, and the RMS value. Where is the RMS value? RMS value is here. Let me use another color. So peak value and RMS value. So peak factor is E maximum by E RMS. Okay, so that will be 140 by 98.99. Kp is always 1.414. For any question, Kp will always be 1.414, and form factor will always be, form factor is E RMS by E average. Okay, so there are three values, right? E maximum, E RMS, and E average. So EM by E RMS is peak factor, E RMS by E average is form factor. That is E RMS is 98.99 and E average is 89.13. So K form factor is always 1.11 for any AC current. A simple question for 6 or 7 marks. You need to compare the given question, given quantity with the general representation of an AC signal, that is Em sin 2 pi ft. Okay. If this video helped you and if you want to learn more, check out our full basic electrical course. The link is in the description. Also like this video and share it with your classmates, and subscribe to the channel and press the bell icon to keep learning.